Welcome to the session on functional programming language, or functional programming on the JVM. The JVM part is going to be pretty small. I'm going to spend most of the time on functional programming. What's the incentive motivation to do it? Some of the features of functional programming, how we can apply it. And then towards the very end, I'll talk a little bit about what happens on the JVM. Now, just a couple of things to set your expectations. Number of sessions that you may have seen, you could probably go back to work on Monday and apply it. This is something that most likely you won't use on Monday unless you are working in a very specialized project. Now, of course, that could be taken as, well, then why waste time here? I might as well, go enjoy the sun. We could do that. Or you could say, learning takes a lot of time. Sometimes we learn things and it takes a few iterations to learn. And so by learning some of the things, as they evolve and they become applicable, we're ready to take it. But there's also yet another reason why we need to learn something that we may not readily use the next day or the next week. One of the key differences is we are in a field where part of our job is to constantly learn. And if you are learning a certain language, if all that you know is one language, then what that means is that your brain is wired to think only in terms of the design and implementation that language allows you to do. But when you learn a different language, and when I say the word different language, it's got to be drastically different. You cannot learn, if you know C++, you cannot learn Java and claim that it's drastically different, right? There's a lot of similarities. Yes, it is different, but it's not a drastically different language. Or if you know Java, you cannot learn C# and claim that you've learned a drastically different language. But if you know Java, you can go learn Ruby, and that certainly there's a lot of paradigm shift when you do that. Or if you know, one language, go pick up a language that does things totally differently. Now, there are a couple of reasons why we need to do that. The first reason is learning a different language gives an opportunity for us to explore different ideas, different thought process. The way you design your system heavily is influenced by what you know. After all, if you don't know of a certain technique, it's hard to really apply that technique in a software project. But when you've seen different techniques in different languages, sometimes it may come and hit you that you could do something like that even if your language doesn't quite support it directly. And that's something that's happened to me quite a few times. I may not be programming, for example, in Ruby, just as an example, right? A few years ago, I started learning Ruby, and I learned Ruby just for the fun of it. I had absolutely no reason to use Ruby at the time. Things have changed since. That's a different story. But I was working on a project in C#, but I was able to use some of the concepts in Ruby into C#. It's the familiarity that you get from the other languages, and then you do things that you never thought or knew how to use it. The pragmatic programmers talk about learning a different language, at least one language every year. It's a responsibility that we take in learning a different language, completely different language, just for the sake of learning, right? That's an investment more than anything else. Aristotle said it's a sign of an educated mind to entertain a thought without accepting it. So sometimes you start looking at things and you may not like what you're looking at. You may say, wow, that's ugly, or that's kind of different. But entertain that thought. It doesn't mean that you have to go do it, but entertain that thought and see, what's the merits of this? What's the disadvantages? There is absolutely no language in the world, right? You would agree with this, I hope. There's absolutely no language in this world that is all perfect and has no flaws in it, right? Have you ever come across a language like that? When everything is right and nothing is wrong with it. Looking for a perfect language is like looking for a perfect marriage, right? That doesn't happen. You kind of, live with the best parts of it, and when things kind of go wrong, you kind of ease a little bit and cope up with it. So it's the same thing. You kind of learn a few things by doing this. But the question is, why should we be interested in functional programming? Now, this is something that's kind of interesting and troubling at the same time. A lot of research has been done in the academics. A lot of things have been applied in the industry. And if you look at a lot of things I'm going to show here, I don't have anything new at all to show you. This has been done for the past 50, 60 years, right? But most of us haven't used it. And the reason for that is, and I used this example in one of my other presentations yesterday or day before, object-oriented programming was introduced in 1967, and by the time we started using it, it was late 80s to early 90s, and when we, as a mass we started using it. Now, why does it take more than 20, 25 years, and sometimes even 30, 40 years before we start using some of these things? And dynamic languages, I want to say that the year 2000, or the decade of the 2000, is the decade of dynamic languages, right? If you look at what's going on around in the world right now, clearly there is a wave of excitement and implementation around dynamic languages. At the end of 2010, most of us would be using dynamic languages in one form or the fashion in a lot of enterprise applications, right, I think. Now, I'm hoping that the next decade, right, getting into 2011 and forward, and maybe even towards the very end of that decade, right, looking at about 10 years from now, if not sooner, I would hope that it would be the time of functional languages. So you say, why is that the case? Why should we be excited about it? I'm going to talk about some of those reasons here. Oh, by the way, the best time to ask a question or make a comment is when you have it. So sometimes I forget to say it, and people usually quietly watch me. That's not the intent at all. I keep rambling if nobody talks to me. So ask me a question, make a comment, I'll slow down. Otherwise, we'll be done in about 10 minutes. What we're going to do is we're going to talk about why we care to do some of these. We've been using object-oriented programming for quite a while, right? We don't question, hey, should OOP be used? We kind of just pick it up and use it right now. And object-oriented programming gave us quite a few things. Remember the time we were using structured programming, and what did good old Dijkstra say? What's one of the recommendations from Dijkstra? That's not the one, no. What was the recommendation from Dijkstra? What did Dijkstra write about? Yes, that's right. He said GoTo is evil, right? He said don't use GoTo, right? Does the Java language have GoTo in it? Can you use it? No, right? So yes, it has it, but you cannot use it. It's actually a forbidden keyword. That's correct. So the indication is saying no more GoTo for you, right? But are you telling me that your program doesn't jump around? That constantly jumps around, right? So you don't write GoTo, or it's not considered to be a good thing to write GoTo. Again, never say never is a statement, right? There's times when it's okay to use it, but a lot of times people abuse it, and we end up with what's called a spaghetti code. So it's not that you should not use GoTo, but usually it's considered to be evil. But that doesn't mean that there's no jumps at all in the code. There's jump going all over. Anytime you call a function, you're jumping. You return from function, you're jumping. You have a conditional statement, you're jumping. So you're doing GoTo all places, but you don't do GoTo. You probably have heard this, sometime, right? If you had a very old grandpa or a grandma in the house, you probably heard them say, back in those days, we never locked our door. Have you heard that, right? We used to just leave our door open, and it was very safe to do it. So, there's certain things like that is going to come back to memory when you look at some of these things here today, is we're going to do certain things or not do certain things because those are not big concerns to us. But there are reasons why we want to implement some of those, so I'll kind of come back to those things. So great emphasis on things like encapsulation, polymorphism, and again, avoiding arbitrary GoTos. Those were the contributions that, object-oriented programming kind of brought about, structured programming brought about, and so on. Now, when it comes to these, programming is a different way of thinking. You're going to be thinking at a little bit of a higher level of abstraction. And so what you're doing here is you're asking, hey, why don't we treat functions as something of a bit of a higher order entity? So rather than just passing objects around to other functions, why not pass functions around to other functions? So if functions are first-class citizens, you can just take these functions and pass them around. Again, if you have ever written JavaScript, you've already done this. JavaScript is not a functional programming language, but JavaScript has some of these features. So this is basically a trickle down, right? So there are certain concepts in a certain paradigm, but it kind of trickles down to these other paradigms. You cannot look at that and say, aha, because you have it, it's part of that, right? It's a subset, it's been trickling down. So yeah, JavaScript certainly has that. So one of the key things about this is an assignment-less programming. So assignments are considered to be evil. And you say, wait a minute, did you just say that I will not assign something to a variable? That's exactly what I said, right? Just like Dijkstra said, Goto is evil, functional programming considers assignments to be evil. So wait, but if I cannot assign, how would my program even run? And that's why I want you to think about gotos, right? Just because you don't use goto doesn't mean there's no jumps. Similarly, just because you don't do assignment doesn't mean there's no assignment. It's just that you don't do assignments and something below in a lower level of abstraction takes care of a nice, safe way of doing it. Now, of course, then the next question is, why shouldn't I do being assignments, right? We'll come back to that in a minute. So functions are treated as a higher level of, as a first-class citizen. One of the reasons to do this is to not have any side effects. Now, what happens if I call a function, right? I remember working on a project, and we had this developer looking at a certain expression, equation, and when we executed this code on different machines, the behavior was very different. There was a problem in the nth decimal place. It took him a long time to find out, and eventually what he found out was this equation was performing an increment operation multiple times, and because the increment was happening multiple times, the result was not the same across these different machines, right? This is a code which is considered to be an extremely bad code, right? Why? Because you call this function, it does some work, it doesn't just give you a result. While it's giving you a result, it's changing a lot of things around it. Now, if I take this function, if I want to break it into smaller pieces, how do I break it into smaller pieces, right? It's very difficult to break it into smaller pieces because it's got side effects leaking all over. So, but why would I want to break it into smaller pieces? We'll get back to that. So, this basically, the reason for doing this is, there is something that's happening now. This is certainly not a funny story for the guy who wrote to me, but I thought this was very funny, right? I get this email from this guy, and his email reads like this. It says, Venkat, don't tell me what's the right thing to do. I already know it. And the right thing to do is to go back and redesign my application. And don't tell me that, because I don't have time for it. I didn't write this application, so I didn't cause this problem, but this is my karma, so this has been given to me. And the problem I have is, this application works okay on this box that we've been deploying in. But my company recently acquired this multi-core processor, and we're taking this application and running on this multi-core processor, and all hell breaks loose. There's the problems, the data consistency problem, things are corrupted. So tell me, where is the blue pill? Tell me that blue pill. I want to solve that, and the problem should just go away. Don't tell me go back and redesign, because I already know that, but I don't have time for it. And I thought that was really funny, isn't it? Right? You get into these kinds of mess, right? You don't have a clue what you're getting into, and all of a sudden that becomes your problem. And he says, I didn't write this application, it was just given to me, what do I do? And I told him the answer is very simple. You walk up to the multi-core processor and change the setting and tell the processor, it's great that you have 2 cores, but no thanks. Turn one off, right? And I don't want to use your beautiful power because my application is messed up and I cannot survive in the power that you give me. So whether you like it or not, you are being dragged into this war, right? We already have great amount of difficulty writing multi-threaded code. We as programmers are not capable of writing good, effective, multi-threaded code. The Java APIs, the dotted APIs are extremely low level when it comes to concurrency, right? And you're dealing with this level of concurrency, getting it right is extremely hard, knowing whether it's working or not is extremely hard, and now all of a sudden, your application is sitting there with threads running across multiple cores, and suddenly all kinds of stuff can start going bad, right? I have actually written code which works fine, all my unit tests pass on a single core processor. My mind thinks through all those problems. Then we deploy our multi-core processor and all hell breaks loose. It's happened to me on my own code. I am incapable of doing that, right? Because my mind doesn't think about these things. I don't understand these things. It's very new to me. And all of a sudden, I'm faced with this extreme problem. How do I write application that can be deployed on these multi-core processor? Like I said, it is not your choice anymore. You are being dragged into this. You could have said, in years before, you could have said, you know what, I don't want multi-threading. And you could have been happily sitting in there, right? But now this war has been brought to your door, and they say, whether you want it or not, we have multi-core, we have multi-threading, and it's a challenge, you better handle it, or else, how do you deal with it? So this is the concern. So that's why I'm saying, as we go into the next decade, this is going to be extremely important, because we will not be able to comprehend and deploy applications safely without a higher level of abstraction that deals with it. Go back to the story of grandma who says, oh, those good old days, we never locked our door. Because you don't have assignments, you're not going to have multiple of these functions that start modifying data and things leaking around and having side effects. As a result, you have multiple threads, you don't have collision. In fact, some of these languages, you can look hard, you can look tall and low, you will not find locks. They don't have locks. Why? Because there's nothing to lock. There is no synchronization problem because no two things modify the memory at the same time. So yes, it is a very different model than what we are used to, right? But at the same time, by removing a certain, things from our hand, it gives an ability for us to achieve that things, and we let the infrastructure deal with those concerns, but we are able to gain on this implementation problem. So at the end of the day, you need to have a problem that you solve with these things. If you don't have a problem to solve, the industry waits until the problem leaps up and bites its back, right? And it's like, ouch, that hurts. Now go back and find what the solution is. Until that time, we don't care. Hey, that's a nice research, and maybe a small group of people are doing it. But when it becomes imminent, we want to rush through and have that, right? So it's one of the reasons why a research is very important, right? The research done in universities, research done in academia is extremely important. Those guys, we look at them sometimes and say, you know what, those guys are doing something totally irrelevant. You know what, a lot of times they do things that are totally irrelevant. But all of a sudden that becomes relevant about 20, 30 years later, and then we're like, thank you, right, for doing that, right? Now how do we, tune that into what we're trying to do? Let's commercialize it, let's display it, and then we get excited and we apply it. So, we're being dragged into this dual-core and multi-core processors. I already talked about this, and we want to be able to deal with this higher level of abstraction. Yeah, but what about these other, please.
On the previous slide, you mentioned that you don't have assignments, you have lesser or no side effects, and because of that, there is no concurrency overhead in maintaining any loss. Does this apply? If I have assignments within the scope of my function, which does not touch anything outside, only on the stack, will that affect concurrency?
It will, right? So let's say you have a function, right? And I have this function which touches some data. I don't have the ability to call this from multiple threads anymore.
No, the function, I'm talking about the data or assignment happen within the function and die when the function is over.
Well, it's like a local variable, right? See, the problem is the local variables invariably are references to something else, right? If it's a pure data value, like a primitive type in Java, yeah, you're not concerned about it, right? But your local variable innocently is a reference to something on the heap. Yes, your local variable doesn't change, but the variable ends up changing other things. So rather than thinking about this as assignment, step up the word a little bit as immutability, right? If something is immutable, this is what we really mean when we say assignmentless, right? So if I create this chunk of memory, whatever that could be, but once you create it, it's immutable. You cannot modify it. Then you have the thread safety. Of course, the concern is, hey, what if I want something different? You start copying. And of course, we're worried about, hey, what about performance in those cases, right? But the thing is that is immutable. So more than saying assignmentless, what does assignment really do? It mutates. So we're talking about immutability. So it's a good question, right? So the real concern is, how can I make this immutable? And by making it immutable, then I don't have to be worried about these concurrency concerns, right? And again, think about this as a concept, whether this is the right way to do it. And again, this is why I was saying earlier, we need to entertain some of these thoughts. If you think about this experiment and actually graduate, right? It was running so slow. Then he went back and re-implemented in a C-like language. It was running fast and furious, but man, it was failing all over, right? And then once he graduated, went down to work for AT&T, and they said, sit down here and think about what you want to do. He said, look, I have this expressive power on my hand, if only it would run. And how can I bring those to the table, right? And the V-table concept and things like that gave you the way to realize polymorphism without losing the power or the speed, performance, right? So once and they're very smart people, right? So you come up with a concept, yes, you may not have a good implementation, but as time goes on, we come up with ideas, right? And say, hey, well, how about this, how about that? And that's the beauty. And what was impossible years ago suddenly becomes a norm. And that is the beauty is we need to understand what problem we are solving, but I may not know the solution, right? But I may say this is the problem, here's what I've done, and something may trigger in your head. It's like, what about this? And then we may arrive at something else. And that's the beauty, is that's the evolutionary path. And it's a very exciting time to be in. And we got a lot of things that has happened over the past 20, 25 years. With the JVM and all those things that are evolved, we got a stronger and better understanding of the technology, and we're trying to map some of those things. That's a really good situation to be in. So you want to be able to, so all these other languages like Ruby and Groovy, what about those? We just forget them. Is OOP dead? No, absolutely not. You're still writing functions in OOP. You're still writing structured code in OOP. But it's not just structured code. Your object-oriented code is using structured code, right? It's a different level of abstraction. Similarly, you're going to be in functional programming, but you're going to be using object-oriented programming, within it. So consider these as, circles, right? You have structured code, you have object code, you have functional code, and you're going to be building on top of it. So it's not a question of losing everything you learned. It's being open and building on top of what you already know and you've learned already. So that's the beauty of this. So you want to be able to use some of these features, and certainly it's an evolutionary path. So the core of the functional programming is these higher order functions and that you want to use. So what's a function? Well, you can say a function is a transformation of an input to an output, right? You receive an input, do some work with it, and you produce an output. Okay, that's kind of a simplistic approach. It's got algorithms, performance, implementation details, all those. Okay, so we can then say it takes a certain input. It's not only what it does, but also how it does it is important. But what we want to do is to have this referential transparency where you call a function and you know that it's a well-behaved function. You send data to it, it gives you an output. Didn't leak anything in between and mess up things, and then you can take that and deploy this concurrently and handle that fairly effectively in your application. So with all that said, if I have an equation, in a mathematical sense, you're assigning something to an expression, but it's more of an evaluation of this expression. That's what you're doing here. So basically, in this case, I could say A is 3. The A is given an explicit value of 3. But on the other hand, if I say x equals 2x minus 3, in this particular case, you're saying, find the value of x that satisfies this equation. And then you would arrive at the fact that x is a 3 to satisfy that, and so on, and you can compute these other things. So it's a different way of evaluating these values in your application. So the functions basically are higher order in these functional languages, first-class citizens. And Lisp has already shown us how you could develop significant applications with it. And so by using some of these concepts, you can express your application in a very effective way. So I'm going to use one language here. I picked up one language which I've been playing with quite a bit, which is a language called Erlang. And Erlang is a language that's been used fairly effectively in telecommunications, as an example. There are stories about how Ericsson has applied Erlang quite effectively, and how they're able to express some of those very high concurrent systems with a great amount of stability and so on. You can Google and read about it. So what I'm going to do is I'm going to just show you a couple of different examples, different ways of doing things. So let's say I want to start with a little example here, and the example I've started here is I'm going to, again, don't worry about the syntax, right? No matter which language you know, when you look at the syntax of another language, it looks odd, right? I've never been able to read a book, close it down, sit down and program. Never happens, right? I read it, it's like, oh, that's great. I close it, and I touch the keyboard, it's like, what was that again, right? It doesn't seem to make any sense, and it's kind of odd. But then you program it for quite a bit, and then it becomes kind of very natural. Your fingers do the typing, not your mind, right? It kind of goes on. So don't worry about the syntax, more so worry about the concept itself. So I'm going to take a very simple example. I want to do this. I want to say result equals double, and I want to double these different values, 1, 2, 5, 3, and 7, right? Take a very simple example. And I want to basically print it out, and I say print the result, right? Now, how do I double this value? I'm going to say double, and I'm going to say double these values which is in this list, right? And that's what I want to do now. Now, at this point, if you're a Java programmer, what are you going to do? At this point, if you're a Java programmer, you're going to say, hey, where's my for loop? right? I'm going to go to the for loop, and I'm going to start multiplying these values. Erlang doesn't have a for loop. Okay, you say, no problem. Give me the while loop. Erlang doesn't have a while loop, right? You say, where's the loop? It says, that's so simple, you create one for yourself, right? So the language doesn't even do it, because it's so simple, why should I provide it to you and you can do it for yourself, right? So it's a very different way of thinking, right? So, but the way of thinking raises your level of abstraction. If I had a 100-pound stone right in the middle of this room, and you say, Venkat, this stone is here, I don't know how it got here, move it. You need about 4 people. Actually, you know what? 7 people like me to move it, right? I'm not going to be able to lift it. Or you can bring somebody half my size with a bit more skill than I do, press a button, use a crane, and move it, right? So a high level of abstraction, you don't have to do as much work, but you got to take the time to learn about some of these things. So what am I going to do here? I'm going to say, I'm going to go to the list. And I'm going to call a method called map. So the list has a method called map. Think about this like a static method if you want to, right? You're calling the map method. The map method, what does it do? The map method says, map is kind of an odd name. The map method says, I am going to perform an operation on each one of these values that you give me. So it is a built-in iterator. So rather than you sitting there and saying, get me the next one, get me the next one, get me the next one, you say, hey you, go do this on all the elements. Don't bother me to keep telling you to go to the next element, right? It's an internal iterator built in. And I want to operate on this collection of elements, which is the L, but what am I going to do on it? So notice the L is the list itself, right? The collection that I want to deal with. But what do I want to do with it? Well, the map says, I don't have anything to do with it. I'm just the iterator. And I do whatever you tell me to do. So what am I going to pass to that? A function, right? So I simply say a function is an element E. I'm going to just send that function. And where the function is going to return E times 2, end of story, right? So right there is the code for doubling these values, right? As simple as that. So you simply say, hey map, take this list and apply this function on each and every element that you have. So rather than me sitting there and looping through, I'll let you do the job. And here's the function, go figure out, right? Now, let's go to Java terminology. You say, hey, I've used this in Java. In fact, you have. And that is called the anonymous inner classes, right? So in Java, these concepts exist, but it's a lot more work for you to do, right? And that's one of the reasons why I appreciate delegates a little bit more in C#. Delegates are object pointers. You know, at the end of the day, right, C program had function pointers. How many of you have used function pointers one time or the other in your life? Most of us have, right? Others are in just denial. They don't want to admit it, which is a good thing to do. You don't want to put that in your resume, right? How many of you want to go back and do more of that today? Okay, we need to talk. But most of us know, right? Why is that? Because function pointers basically are horrible. They torture us, right? But you can encapsulate it and sugarcoat it. At the end of the day, function pointers are very powerful if there is a way. That's why encapsulation, right? You swallow it, it's not bitter, but you enjoy the benefit of it. So that's why it's elegant here. You just pass it around. That's what you have done. So what have I done? I've just passed a function to this and said, go do your job. That's all we did. All right, move on. So what I'm going to do here, see how you can do this in Groovy. Well, you can do this in Groovy as well. Like I said, these things have trickled down pretty nicely to other languages and what's available for us. So let's look at an example real quick. I'm going to take the list object on hand. So list. Okay. So list equals 1, 2, and 3. That's good enough. List collect. So the collect method says operate on each of the elements, but whatever the elements return to you, put them in your pocket. When you are done, take that and what you collected, return to me. So collect what? I'm going to collect 8 times 2, and I'm going to print it, right? So if you notice what's happening in this particular code, I'm simply looping through and printing, and you can see the result. You probably would agree that this syntax is a lot more elegant than the syntax we saw on the other side, right? And that's one of the things is the languages come halfway, and you go the other halfway, right? So languages, the syntax and the ability to use it they got to be coming down to the level where we can comprehend. If it's ugly syntax, it's a very difficult syntax to use, then a small elite set of people who enjoy taking that pain, like the guy over there who said he eats function pointers for breakfast, right? He's going to be happy using it, but the rest of us are like, oh, that's not for me, right? But you make the syntax really elegant, then most of us are going to enjoy it and use it. It becomes commonplace. We're able to benefit from it. So that is basically the example of where we can, right there you can see that being applied within Groovy itself into much more elegant syntax. What I'm going to show you next is another interesting concept that's happening here. Now what I want to do is to show you how another concept of functional programming languages, which is the ability to treat at a higher level of functions or equations. Let's say I want to print out a format, a factorial of a certain value. Well, what's factorial of 0? Factorial of 0 is 1, right? So basically I'm going to say 1, and I want to print it, right? That was easy. Then I want to say, what's factorial of 1? Well, I can say factorial of 1 is also 1, right? That was easy. You say, okay, Venkat, what's factorial of 2? If I go right factorial of 2, you're going to say, hey, I'm leaving this place, right? This is not going to end. Well, if you factorial of 2, let's write it like this. Factorial of n is factorial of n minus 1, right? And then you're going to say times n, right? And then you're going to say, what is factorial of 7? Is that right? I hope so. Okay, so you can see how you just basically took the expression or equation, and the language says, I'll do it, right? You don't have to sit there and break it into smaller pieces. You don't have to sit there and write recursive calls. It says, I'll do it for you. Notice the higher level of abstraction, right? So think about that for a minute. You know, yesterday and maybe part of today I was saying, you could write your code in Java, but in places where you can take advantage of DSLs or metaprogramming, you can jump over and start using Groovy. Now I'm saying, hey, wait a minute, you can write your code in Java, but in places where you want to take advantage of mathematical functions, maybe you can switch over and start using a functional language, right? There are certain banks which do extreme amount of financial computation. And what these guys used to do was they would take all these mathematical models these guys develop, and they'll give it to these poor programmers which sit there and code it. You know, if you give it to me to program, what will I do? I'll only get half of it correct, right? And then I go show them my C# code or Java code, and those guys first paint, right? Then they work and they try to find out if what I've done is right. But if you instead show them the equations itself, they're like, yeah, that's what is right out. No, this is not right. But then you start executing that equation. So there are languages like F# that are available right now that's being used in these industries, right? But the beauty is, you're not saying, okay, good luck, but that's all you can use. You can interoperate with .NET, you can interoperate with Java and so on. So that is the name of the game these days. It's not isolation. It's not like if you want to go away and do something else. Well, if you want it, you can interoperate and mingle it, right? You can do your stuff here, but branch off and interoperate and come back. And that is the beauty of some of these approaches. So, please.
You mentioned that Groovy and all are more
Dynamic languages. Mm-hmm.
Do you have an example of the currently implemented functional language? You mentioned F#.
So F# is a language Microsoft has developed on the CLR. There is Erlang that I'm showing you here, but that's a functional language that's running right here in front of you. There is also Scala, which runs on the JVM. There is also Haskell, which is an implementation of Haskell that runs on the JVM, and so on. So yeah, there are certainly, but again, we're still in the initial phases of evolution, right? So you're on the bleeding edge if you start using these. Just be aware of it, right? Maybe 20 years from now, or if not, okay, let's be even more optimistic. Maybe 40 years from now, things will be a lot more stable and things will work. So then, if you are dabbling into these, you are working with bleeding edge. And there are certain projects that deserve it, and you're much better off it. But if not, a few years from now, most of us are still even experimenting and testing the waters for dynamic languages. So that's why I think this is a bit more farther away for most of us to use, but that doesn't limit a few of us to jump in and start benefiting from it. Question or comment from somebody on the other side? No? Okay.
That we're able to show that
that's where the trickle down comes in, right? So, my cat has blue eye, but not everybody with the blue eye is a cat, right? You see what I'm saying? So, for a trickle down, okay, great, I am able to pass these functions around, that doesn't make it a functional language. That's just one aspect of it. And we're trickling down and bringing things in, and that's the beauty of it. So, given this, we looked at how to use these functions. What I'm going to show you here is yet another use of these kinds of functions. Let's just do one more thing. I want to develop a little Fibonacci series here. So it's a 1, 1. It's a very poor font. Okay, color. So 2, 3, 5, 8, and 13, right? And so on. So how do I bring this series? So I'm going to say, print out a series for me. And the series that I want to print over here is a fib value for, let's say, 1. Well, that's very easy, right? So I can simply say fib value of 1 is simply a 1. Similarly, fib value of 2 is simply a 1. Well, fib value of n is going to be, as you know, you basically take the fib of n minus 2, and then you add fib value of n minus 1, right? So basically in this case, if you start with a value, you subtract 2 and subtract 1, and then you equate it. So in this case, I could go back and say, tell me the fib value of 3, and it says it's 2. Fib value of 4, it says it's 3. 5, it says it's 5. 6 is 8, and so on. But you say, okay, but I want the series. How do I get the series? You can put them together if you want to, right? So I'm going to say, get me fib series in this case for a 6. So I'm going to say a fib series over here for n. Let's start with something simple, 0. So the fib series of 0 is a fib of 0 itself. So notice how I'm building it, right? So just give them some examples and then extrapolate it, right? Mathematically, you can say if this is true for n, true for n plus 1, and so on. So it works very close to that. So similarly, I could say a fib series of n is going to be a fib series of n minus 1. And then I'm doing a plus plus because I'm dealing with a collection, not a single value in this case. This is append or concatenate, right? And then I'm asking him to get me the fib for n itself. I don't have a clue if that's right, but we'll find out, right? So basically in this case, I'm simply asking him to go through these values and add them. Obviously, I made a mistake, something here. Who wants to fix that error here? Fib of 0 would be... that's right. So that's going to go into a while loop for a while. So that's some of the things you need to be aware of, right? It's nice to make mistakes, so we can see that's how you blow things up. So you have to, put them in the proper order. So you got to make sure it converges and so on. That's something that you have to do properly. So I'm not going to wait for it. So let's go ahead and crash them. How do I do that? Okay, so what I'm going to do is, let's continue further here. A little slow. There we go. All right, so open the file that I had. So let's go back here. I wanted a fib of 1, correct? 0. So what's going to be, actually that's not a valid number, right? 1 is enough for here. So I'll just say 1 is going to be 1 since I'm starting with the 1. Will that be enough? One way to find out, right? So the value basically can be built up pretty effectively by going through some of these sequence of operations, right? That's what you're doing here. So, a little unresponsive here. There we go. So the value is basically basically can be computed as a series of these expressions, and you can build on it. So essentially, you're relying on pattern matching. So what does pattern matching really do? Pattern matching says, it's kind of like having all the coins and you want to sort these coins. You can just drop them through and say filter through. So when you call this, it says, I'm going to look for a fib 3. Oh, I don't find it. So I'm going to call fib n because n is a variable. Once it kind of transforms it, or it reduces it, is probably a good word to use, and then it goes and looks for fib 2 and then fib, and then says, oh, look, I find that, so I'm going to go call that. Now, one of the small consequences here is, when you do that, you want to make sure that you are calling this with smallest value to the higher value, or the variable, or depending on what the pattern matching is. So in this, again, this is kind of implementation specific, is that it sequentially searches through these, so you got to be careful in which order you present some of these details. So, continue on. And we'll entertain some of these thoughts. I want to find the maximum of two values. How do I do that, right? And then we'll talk about finding a maximum of series of values after that and see how we could be able to do that. So let's go back and look at an example of finding max. So let's just say max 2. So I want to find the, a little sluggish still. Okay, so I want to say max 2 of 2 and let's say 1, right? That's what I want to find the values of these two. How do I implement this? Maybe I would also ask him to find the max of 1 and 2 to make sure it's giving the right value, but that's okay, we can just try this. So what does max 2 do? It takes an A and a B, but how do I find the max of these two values, right? Again, you could sit there and write an if-else statement, or you could use pattern matching. And you could say, why don't you just compare these values, and if a condition applies, then you can take a certain implementation. So I'm going to say here, when, right, A is greater than B, I want to simply return A, right? And then I could say max 2 of A and B, if that condition is not being met, simply return to me a B itself, right? So essentially in this case, don't worry about the errors or warnings you will get in this case, we'll fix it later on. But if you notice, you're simply applying pattern matching one more time in this case. So you're saying, go back and do a max of 2 and 1, but apply this pattern so the when becomes part of the expression. And you're saying, if A is greater than B, then I want to apply this and then pull it in and return the value of A. Otherwise, I want to return the value of B itself. So that's what we're trying to do here, right? So if you look at this result, where is he complaining? Syntax error before B. Over here? Line 7. You guys are picky. Are you happy now? Okay, so it's basically giving you the result. You can see that at the bottom, right? Ignore the warning for now, we'll fix it in a few minutes. Now, I want to go through a series of values. How do I do that? So I'm going to simply say, see if this makes sense. I want to say max of maybe 1, 2, 5, 6, 7, 8, 2, and 8 again, right? So there's 8 a couple of times in there. So I'm going to send a series of values for this max, and I'm going to send him a collection of these values right here, right? So I'm going to deal with an array. Well, how do I deal with this array of values? Now, that's another beauty in these functional languages is that they treat these collections as something of a higher level of abstraction. So if you take a collection, a list, you can split the list very easily into the head of the list, and the remaining you could consider to be the rest or the tail of the list. Because it's such a common operation, you can work with this very effectively. Let's take baby steps here. Before we go further with that, give me 1 second. If I go back and fix that little warning, I don't want to work with the warning there. So basically, in this case, if I execute it, he says he doesn't like it, and the reason for that is the value of A is not being used here. So you can put an underscore for him, and then he's happy with it. So that's just a placeholder. It's a wild card, if you will, right? That's all it is. So go back here with this. So I'm going to take a series of values and use it. How do I do that? So just put a little value here, That's good enough for now, right? Okay, so how do I deal with this? So I'm going to say max of a list. That's what I'm dealing with, right? But the beauty is, if you're going to be operating on the head and the rest of it, you can already do this. You can say I've got a head and a tail, right? So it literally takes this and splits it at the time of call. So notice the theme that you're seeing here, right? It's a higher level of abstraction. So rather than you saying, get me the head and go get me the remainder of the elements, it already does that. So basically H is going to be what? 1. And then T is going to be the rest of it. Let's just take a look at it and see if it's true, right, before we go any further. So I'm just going to return the head itself in this particular case. That's got to be a max, right? So I'm going to just return the head itself in this particular case. And so what did he give in this particular case? He's complaining about max 2, but let's ignore that for a minute. Notice he gave a 1. On the other hand, if I say T and return the T itself, notice he gave the rest of it. So you can see that it's already splitting it, right? So what I'm going to do is to take this and say, now help me with this. How do I compute the max now that I have a head and a tail? Max 2, or is it max? First thing is look for the ending condition. Max of a head with no tail. He's a head. Make sense? Because you only have one element, right? So you're talking about the end condition. Saying if you give me a call max and you give me a head and no tail, well, max is the max because I only have one element in this case, right? Now that I can reduce this, I can say max of this is max of what? Head and max 2 of, right? Max 2, actually, should I do that? Call max itself? Okay, what do I do then? So I got these two values.
Max of T.
No, I can't do that, right? Because I already know how to do a max of 2. So I'm going to say max 2 of H. Yeah? There we go. Will that work? So max of H and T is going to be max 2, which is the two values I get. And I'm going to send in the head and go find the max of the elements until the T. So let's see what the error is in this case. Line number 6 over here. Yeah? So notice how he found the value. So you're saying there's a head and an empty list for the tail, and he's able to find the result. So it's a different way of thinking, right? And you apply a different way of solving the problem. That's what it gives you. Okay, that's great, but still, why should I care to do some of these things? The next thing I'm going to show you here, I'll skip that. So the lambda calculus plays a very important role here. So what does lambda calculus say? It's a way to mathematically work with expressions and even to the extent prove expressions correctness and so on. And in the case of lambda expressions, you are expressing a certain functions in a way that you can prove it. Now, Peter Landon talks about this. A little bit of syntax sugar helps you to swallow the lambda calculus. The concept of closures and all that emerge from this lambda calculus, it's a way of expressing your expressions in a way that you can prove, and at the same time, it's a higher level of expressive power. That's what we're dealing with. Now, I mentioned about the list type already, but what you can do with these list types is you can have some operations on these lists. Let me show you an example of how you can perform these operations on these lists. I talked about this double earlier, but I'm going to show this to you in a different way. So if I say double value that I want to find out, let's just throw this away for a second. I implemented double using the list map earlier, but I'm going to do this a little differently here. So I'm going to say double, and the values I'm going to give here is this. But the beauty is, this is one thing that I probably like the most in terms of the list comprehension. Here is a list. Now what I'm going to return is this. Read this in English as this. I'm going to return a value x times 2, right? And I'm going to say where. So you're basically saying, here is an element I want to return, but there is a certain condition I'm going to place in terms of filtering it further. So I'm going to say where something is going to happen. So in this particular case, I'm going to say where the value x comes from this collection that I have with me. So I'm going to say X is a member of L, right? So if I only execute this, notice what it did. So let's read this in English, right? You're saying return to me X times 2. Okay, that's good, but what in the world is X? X is an element of L. So a list comprehension has 3 parts. The first part is the one that executes the last, actually, but the first part is the operation you perform. The second part is called the generator. The generator is the one that generates this collection of data for you. And there's a third part. The third part is the filter. Now, for example, if I want to only find the double, not of all the values, but only even values, then I put a comma, and I'm going to say X is, reminder 2 equals to a 0. So I'm going to say rem2 is equal to a 0, right? So you can start specifying some of these details and say, go find all the values in this collection, but then start filtering it. If you're thinking about SQL commands, right, it's like performing a query on the database, but you're saying, go find all employees, but only employees who live in a certain city. Now go take out their age and multiply it or whatever that you do with them. But instead of a database query, you're performing a query on a collection. If you're familiar with C#, you probably heard of link. That's kind of what C# is trying to do with link, is to perform these queries. But look at the elegance. It is terse, right? It is extremely terse, but look at the power. You didn't sit there and write a lot of code. It is extremely expressive. If it hurts your head, that is good. It should, right? That means you're still awake, right? So it says, multiply X by 2 where X is a member of this collection, and filter it further by only giving me even numbers. So you can start refining this. This concept is called list comprehension, and that is extremely powerful concept. It's a very high expressive power. Now what I'm going to talk about a little bit is where do we use this. Like I said, the justification for this, one of the justifications for this is the multi-core processor and so on. So here is an example from Erlang. Notice what this guy does. I have a process where I'm sending all these numbers. Then I say do work, which takes a caller and an element X, and I'm multiplying this element that you give me, doubling it, and I'm sending this. So basically this gives you a message passing. Excuse me, if you cannot mutate, if you cannot modify the data, how do you work with it, right? So notice in this particular case what's happening is there's a process you can spawn. So only look at the areas that I'm asking you to look at. If you look over here, process L, I say caller equals self. This is where every piece of code, it's a lightweight process. So I say, what's my process ID? Oh, that's caller, right? Then I say map on the list, spawns other processes. So this is like lightweight threads, right? You're just spawning these processes, but these processes could be running on any of the cores. And because there's no side effect, you don't have to worry about corrupting memory from one to the other, right? You're not locking. So you spawn this process. Well, what does this process do? He calls do work. And you get the PID back, which is a process ID. Now you have a collection of process ID. So those guys are gone and they're working on their own stuff. If you look at do work, but when do work finishes its multiplication or doubling this value, he has the result, but I need to get it back to where I need it, right? How does that work? This is extremely a terse syntax. The bang that you see here, right, this one here, the bang is a message passing. So you're saying, go to the process whose ID is this value and send him this tuple, this set of value, right? So you're sending the tuple to that particular process that's been launched. That's how you do inter-process communication. So as a result, he receives the result back. So if you notice here, the working is all printed by this guy here in a separate process. But then, all these processes are sending a response back, but how do I know what to receive? Notice once he launches those processes, he comes down here and says process response, and the process response says, I'm going to take a collection of process IDs. And when I get a process ID, a receive method waits for a response from a remote process. When I receive it, I take that value and print it out, and I go back and call it, and I repeat this until my process list is empty. Right, recursive call to do this. Now, this is a way to launch processes. You can see, again, ignore the syntactical complexity, but essentially how simple it is to communicate between these two. Of course, when you look at this, you say, oh my goodness, but what's going to happen in terms of performance, right? In Java, have you tried to create threads? Sure, right? Most of us have done it. How many threads were you able to create? Most of us, we didn't care to go that far, which is good, right? But how many were you able to create in your application or in your test program or prototyping? Anybody remembers? Yeah, in thousands, right? You couldn't hit more than that. When you go to thousands, you got what kind of problem you had? Out of memory exception, something like that, right? So notice this. I created 10,000 processes. And here's the time it took to create these processes. So time to create 10,000 processes was less than 50. What am I printing here? Right? So I have basically called this process, and now this process doesn't do anything, as you can see. So there's absolutely no computation involved in these things. It's just the time to call these and get back a response. And this took 50 microseconds for creating 10,000 processes. Right? So you can see that it's pretty efficient as well to launch it. It doesn't take a whole lot. So, yes, please.
The number of threads running on a
Scala implementation. It's mature, but at the same time, it's evolving right now. And so you have the pleasure and the pain, right? You try it, you're on the leading edge, it works great. If it doesn't work, guess what? You're part of the community. You evolve it, you find problems, you help them fix it, and so on. Be ready for doing that. If you say, hey, everything should work for me, then just wait and watch until it stabilizes, then you can come out and use it. So here's a very trivial, dumb example, if you will. This is where I have just called into Jaskell using JRun script, where I say add A and B, and this is running on the Java virtual machine, right? So I say list equals Java util array list.new. It's a little bit of a different syntax. And I create the list, I call the size on it, just to show you that here's a Haskell program that is talking to the Java API, right? Now, most of us probably have played with Ant, right? So I talked about Gantt yesterday, where Gantt is a groovy wraparound to Ant. There's a little tool called, I don't want to use the word product, called Neptune, and that allows you to write Haskell syntax for expressing the Ant scripts. So if you hit XML, you could use Haskell to write Ant, and then that converts it to Ant and execute it. So just like using Groovy using Gantt, you can use Neptune using Haskell to talk to Ant, for example, right? So you're going through a Haskell compilation and translates to Ant behind the scene and so on. So there are these little things that are around there. Again, depending on what your need is, you may be able to benefit from some of these. But to me, I want to at least look ahead and say, hey, what are these things? And it may also shape the way you design your application. Next time you go back and sit down, these thoughts are in my mind. When I write an API, I say, why don't I write the API in a little bit more easier way to use it? Can I raise the level of abstraction? Can I bring an iterator inside so you don't have to be doing this? So it changes the way you design the system. So one benefit, like I said, is it improves the way you design your system, or at least it changes the way you design the system. The other is you can have these integration points where you can take benefit of some of these things. So to conclude, a bunch of little references if you're interested in taking a look at it. Functional programming is, I really wish that we learn more about functional programming in school, right? Sometimes we learn a little bit, but a lot of times, this is a problem, right? A lot of times we rush towards what programming language the job market needs. Well, we need to slow down and say, let me just spend the time learning some other things that I may not readily use, but it come back and impact. So hopefully that kind of whets your appetite and say, hey, look, this is a different way of doing things. Even though it's not new, it's a very powerful way, and maybe we can apply this to a certain degree in the next few years and to a greater degree as time goes on. So questions, comments from you before we say we're done? Yep.
As you said that assignmentlessness is one of the things, immutability. But then when Haskell is running on top of Java and the Java objects themselves being immutable, I was just wondering how that fits together.
Right, that's a good question. So what's going to happen is there's a mapping between these languages to what's under the hood in the bytecode level. So key is immutability.
So will I be restricted in using only immutable objects?
No. If you want to exploit concurrency, then it will result in immutable objects.
Okay.
So that's how they will be able to give you concurrency. Again, it depends on the languages and how they are mapping, but that's something you can kind of keep an eye on, right? Immutability can give you that kind of ability. And there are other places where you would not get the benefit of concurrency, but you can get the benefit of these higher order methods. So again, it doesn't have to be an all or nothing proposition, right? If I want concurrency, yes, I can gain that. And there are other concepts, that we didn't even touch today that gives you the ability to have these little localized areas of execution with concurrency, and depends on the language concepts that provide you that. So that will take care of the concurrency model. But the other model is you may not really have this benefit of concurrency, but you can take advantage of these higher order functions. And your API, is structured differently. It gives you just like how dynamic languages give you the meta programming capability, these can give you this higher order functions to deal with. So it depends on which kind of area. And that's where it's going to become interesting, because you're running on something that's not built for functional programming. Until that evolves to it, there's got to be a mapping where you get half of this and half of that, and issues related to that also is a bit of an unknown. Yeah. Yes, please. Into a functional programming language? That's a very good question, and I hope not, right? And I say that I hope not because as much as I like languages, right? To kind of go back to the question, and I'll say it in a different way. When I teach a course on C++, or when I sit with the team and talk about C++, I'll point about all these problems in C++, right? And then somebody would come to me and say, will there be a time when all these problems will be solved in C++? I would tell them, actually they solved all these problems in C++, but when they got them, they called it Java. Right? And that is what I want to do, right? You don't want to take your language and tweak it into something it is not. Because then what happens is, it then ends up being none of those, right? So it's a learning process. As human, we are learning these things. Nobody knows these things, right? And sometimes we come with bright ideas, sometimes we come with pretty bad ideas. And then we say, okay, now that we know what these are, let's refactor all of that, right? Start from ground up and let's build it, right? Then you can do the nice things, and yes, while you're doing it, you'll make some mistakes, but that's a learning process, but you're not carrying the baggage of all of that has come with it. So at some point, I hope the language designers would have the courage to say, I'm done. I'm not going to mess with this anymore. It had its lifetime. It's time for you guys to move on to other things. But language designers don't seem to have that courage. They want to say, oh yeah, we want to stay relevant after 30 years, and we'll keep doing this and doing this and doing this, and then it becomes, it just falls under its own weight, and it's not able to sustain it. So as much as I love Groovy and I use it, I hope that they don't keep hacking it beyond. It comes to a sense, okay, this is it, this is where we're going to stop. If you want this, great, we're going to do this really well. If you want something else, go find out what that is. And it could be the same set of people involved in the other language, right, they're creating, and they can refactor. That's, again, my personal opinion, right? If you talk to Guillaume and all the other beautiful, wonderful guys that are working on the project, they may say something totally different. But that is their choice. But that's my personal opinion. Yeah. Yes, please.
I just on a book here. And do I need to do a specific mathematical course to, learn the book?
No, not at all. No.
What level of mathematical knowledge is the prerequisite for this?
Let me say that I did not take any special course than all the math course they have asked me to do through my life. Somebody said, math courses that you do in school, the only reason you do it is that you can go do that in the college, only to figure that you will never use it again, right? Well, I'm just being funny here, that's not entirely true, but it depends on what kind of job you have also, right? Some courses involve some professions involve extreme mathematics, Others probably don't, right? So I don't think I'm working in an intensive math application in my life, even though I've gone through graduate school, and so I didn't do anything special to be able to pick these up. But again, of course, if I'm in an application project, that is where the domain comes in, correct? So it's kind of like saying, how do I apply this? Do I need to know all these sciences behind it? No, you don't. But then if I'm going to sit down to write a mathematical equation, I would need the domain experts' help to do that. So no, you don't need extreme mathematics to write it, but yes, you would need mathematics to implement it on a real project.
Okay, but my question also was, you've seen a lot of lambda calculus and things like that.
Right.
Basically, even they are mathematically, they are a lot into mathematics, right?
They are, but I would argue, so that's a very different question, right? Forget about lambda specifically, just talk about programming in general. You have to always push yourselves one level below the level of abstraction you're dealing with. And you need to know, what does that mean? What is it doing? So if you're working with a certain level, for example, going back to the examples of familiar things, when I teach C++, when I learn C++, I wouldn't say, here's what polymorphism is. I say, here's what polymorphism is, but let's go dig and find out how in the world it's working. So my students actually sit there and draw V-tables in the class. I torture them, right? They draw V-tables, but when they go back, they say, I don't want to know just what polymorphism is, I want to know what's actually behind the scene. So certainly go one level of abstraction below. Understand the theory, but also understand the principles and the implementation behind it. Yes, I would say yes, you have to know, not for using it, you have to know for sleeping well in the night, right? Then I say, okay, now I know there's not a magic happening, and I know the science behind this, and the engineering behind it. I want to know that. So from the point of view, curiosity, I always want to know more than just using it. That doesn't mean I understand it, right? That's a different question altogether. If you ask me, Venkat, have you understood this fully? I hope I will be able to understand this fully before I die. But no, I'm still struggling. But that's the beauty. Every time I look at this, every time I talk to people, every time I ask questions, there's a level of onion I'm peeling. I'm understanding a bit more. But I would be lying to you if I tell you that I understood everything that's happening here. But that's a struggle we constantly have to make. It's not easy things. It's quite complex behind the scene. Please.
There seems to be a lot of support that is needed from the JVM to support all these languages, right?
It really depends on how tactfully these language implementers are mapping it to constructs that are available. And that is what surprises us the most, right? The bytecode and the JVM is so darn strong that seems to be supporting all of this without actually changing a whole lot. That is not to say that it doesn't have to change, doesn't have to evolve, but all these powerful languages have been implemented with almost no change to JVM or the bytecode. And these are reality working, right? If you asked this 2 years ago, we would say, oh, we don't know. But these guys have come along without touching the JVM, without touching the bytecode, they have implemented these languages. Needless to say, these can be improved, but they are working right now. So that is where it kind of shows that the JVM is actually pretty strong.
With this, a lot of multi-core processors coming into picture, there's a lot of discussion going on that maybe there's some changes that are needed to fully harness the power of those processors.
No doubt, right? Why? Because my argument is the language is only half the story. If you're going to start talking to the Java API, if the Java API is not going to be able to support the concurrency, the language is going to dance around this API, but the API implementation, the libraries aren't going to support it, right? So yeah, absolutely. But again, it's the barrier of entry. Once you can show to yourself, hey, this is possible, then you can clearly start identifying areas that needs to be revamped and areas that need to be addressed. And maybe I'm just saying, maybe there'll be a much more effective concurrent library that will be there that could be used with these languages, leaving behind the legacy for applications that don't need it or existing applications. But I don't know the answer for it, right? This is something we need to know how it's going to evolve. But you're absolutely right. That's why I'm saying there's going to be a lot of improvements, changes even fundamentally, not only to the library, but the JVM itself. But the beauty is we didn't have to wait for that. So that's the beauty, is that we have a nice lockstep process. See that's working, now what can we do to improve this? And there's quite a bit of discussions around it. Please.
Domain-specific languages, is functional languages domain-specific language?
No, because functional languages, as we saw here, are general purpose languages. You're still, okay, you could say these are a bit more tainted towards, tainting is probably a bad word to use. They're probably a bit more desirable and focused on mathematical aspects of things or domain of things. But even that, math itself is not a domain, right? Because different domains use math. I could use math in finance. I could use math in astronomy. I could use math in various other fields. Chemical engineering, we do extreme amount of math. So that is where the domain expression comes in. So that is still pretty broad. So no, it is still general purpose. It's general purpose within the confines of the generality, right? So no, I wouldn't call these as DSLs, but they could be used for building DSLs within those domains, because domain is even more narrower than that.
Venkat, would you say that there is any correlation between the strength of a type system of a particular language and its applicability? For example, if I say that Groovy as a dynamic language cannot be, or it's difficult to be applied for functional programming or functional language, would you say that there is any correlation?
So this is a very sensitive issue, right, in a lot of people's mind. This is an area where I find people actually have religion, right? You find people, this is the analogy I draw to this is like the Gulliver Travels, where the Lilliputians are sitting there and fighting whether I should break the egg on the the bigger end of the egg or the smaller end of the egg, right? So there's the Lilliputians, we're all Lilliputians in this area, and the dynamic language guys keep shouting that that's what works and don't have to do anything, and the static language people keep saying that it doesn't work. There is space where static languages may be better suited. You may be more comfortable. There are places where dynamic languages are definitely better. But I want to make this distinction. This is something that I'm still evolving in my head. But I want to make this claim that there's a big difference between typing versus the dynamic language itself, right? Scala is a dynamic language, but it's statically typed. Groovy is a dynamic language, but it's optionally typed. It's got both static typing and dynamic typing. Ruby is a dynamic language, but it's dynamic type. But all the languages just mentioned are strongly typed at runtime, right? So, but on the other hand, C and C++ are statically typed. But you run, and you could pass objects of wrong type, and things will break, right? So it's a weakly typed at runtime, but statically typed at compile time, right? So a compiler gives you a certain amount of benefit, no doubt. I'm not trying to discard the use of a compiler, right? But beyond that level, just because a compiler compiled my code doesn't mean it's right. It is just a first level of defense, right? Stuart Holloway, makes this claim. He says, in 5 years' time, we will consider compiler as the weakest form of unit testing, right? It's a very first level of defense. That's what it gives you, right? Now, so yes, if that is beneficial to you, certainly use it. But that doesn't mean that's the begin and end all. If you take the approach of test-driven development, where you actually make sure the code is not only written, but actually not only, is that it's expressive, but it also does its job, then you don't as much depend on the compiler to give you that support. So no, I don't entertain that notion that a static language is better suited for that particular area. It's more of my comfort level. If I'm working with developers who don't have the discipline of writing unit tests, I'm not going to say that's actually good that they will survive better in a static language, that they're going to get even more bleeding in a dynamic language. It's going to be complete chaos. It's going to be more of a failure, I would say, than in a static language. But ideally, I would much rather have intelligent developers who practice development with tests and then take advantage of these dynamic languages. If you had asked this question to me 4 years ago, I would have said, dynamic languages are stupid, don't use them. But those were the days, I had no clue about test-driven development, right? I had looked at them, I had discarded them, I said, that's not for me. And then it dawned on me one day, that is a way for us to get actually better in developing applications. And that's when I realized, you know what, that is a ceremony that I've been clinging on to, but the cost has been very high, the benefit has been marginal. Whereas here, the cost is there, right? I lack the power of the compiler, but not having that gives me the enormous benefit. But I want to actually, this is a thought I'm evolving in my head, and it's a blog entry that's still waiting to happen once I know what I'm going to talk about. But I'm going to kind of tending towards this claim that there's a huge difference between this dynamic typing versus dynamic languages. And real benefit is not in the typing system, but in the dynamic behavior itself. And that's what we need to be really focusing on. Well, I'll hang around if you have more questions. I don't want to hold these people here, so thank you very much.